All right, good morning, guys. Happy Friday. I'm actually recording this on Wednesday, getting everything out of the way because Friday is Good Friday and we have it off. So, this is a lesson that technically, you do not have to do, I guess, or you don't have to do it on Friday, but get it done at some point. It's really easy. It's one that you'll probably find that you like a lot because it's just solving. So, solving radicals. Very first thing we need to do is isolate the radical on one side of the equation. So we are going to subtract that 5 to get 7. Now, we're just trying to get x by itself. So you need to raise each side of the equation to the power of the index. Our index is a 2. So we're going to raise both sides to the second power, and that will give us x equals 49. So the thing about when you solve radicals is you always have to go back and check to see if there are any extraneous solutions. The big key word in extraneous is extra solutions that do not work. So what we need to do is plug in 49 back into the original equation to see if this works. Now you may be thinking, the square root of 49, 7, plus 5, 12, duh. Yeah, so I'm perfectly fine if you can even stop right there with that line. If you see that it's going to be 12 and you see that it works out, that's great. But sometimes they will not work out, okay? So I will keep going and show you number 4. So for number 4, the very first thing we need to do is subtract 10. We are trying to isolate that radical and get it by itself. Then we will square both sides. And that will leave us with 6w minus 5 equals a positive 49. So we will take that positive 49 and add 5 to it to get 54. And then w will equal 9 when we divide it out. So what we have to do next is check to see if 9 works. So we're going to plug in 9 right back to the original equation. Add 10, and that will equal 3. So we're asking a question here. We're asking, is this true? Is this statement true? So we'll do 6 times 9, which is 54 minus 5. And then that will give us the square root of 49. Now, we know that the square root of 49 is actually positive 7, not negative 7. And we are not using the negative here. So that will be 7 plus 10. Does that equal 3? No, it does not. So our answer right here is not true, right? So we're not going to circle it. We're going to draw a line through it. And our final answer is no solution, which you can also write as the circle with the line through it, okay? So there's nothing that will work where you can plug that in where those values will equal the same, okay? So let's go on to number 5. Now you see a 1/2 here, or for number 6, a 1/3 there. Sometimes they will set these up as rational exponents, but from our rational exponents lesson yesterday, you know that anything put to the 1/2 power is really just a square root, or anything put to the 1/3 power is really just a cube root, right? So they're just writing that a little differently to kind of help you guys out and help you understand that. Now, one thing I really want you to understand and really want you to see is for all these problems above, 1, 2, 3, 4, and even number 6, you are adding and subtracting. But look at number 5. That negative 9 and the square root are being multiplied. So we need to divide by negative 9, not add 9. That's something that I honestly remember from last year, from previous years where people are always trying to add 9 to that because they did so adding, subtracting in the previous 4 problems. So be very careful with that. We're going to square root both sides, and that'll leave us with c minus 12. 16 equals c minus 12, and c will equal 28. So then we will check that. And we will plug in that 28 into -9. And I'm running out of space, but that's 28 minus 12. And that should be a square root. Let me just rewrite that all over again. -36, -9, square root of 28 minus 12. Okay, so we'll take that 28 and subtract 12. And that will give us a square root of 16. And we are asking, does -9 times 4 give us -36? Yes, that's true. So we can take that c equals 28 and box it in or circle it or whatever you prefer. Now, let's look at, let's see here, which other ones do I want to do? It's pretty straightforward. I don't want to waste too much of your time on straightforward things, but understand that for number 7, since this is a fourth root, to get rid of this, I'll just do the first couple of steps here because you can obviously go back and check in the answer key to the notes and see what the answer is. But for number 7, since this is a fourth root, you need to raise this to the 4th power. You're not just raising this to the 2nd power every single time. Same thing for number 6. You would raise that once you get it isolated. You have to get it isolated, that radical by itself alone on one side of the equal sign before you raise it to a certain power. But then you're going to raise it to the power of the index, right? So that's what you would do to get rid of those. If it's a square root, raise it to the 2, cube root 3, fourth root 4. Now, sometimes, like in number 9, you will have 2 radical signs alone on either side. So all we have to do here, it makes it really nice and easy, is square both sides already. That'll leave us with u equals 8 equals 43 minus 2u. You can solve that out from there. I just wanted to show you, sometimes people start to freak out when they get to things like this. Number 10, you do the same thing, except you'd raise it to the 4th power. For number 11, we're going to do the same thing, but understand that there are coefficients in front. So the very first thing we can do is divide both sides by 4 to only deal with one coefficient. That'll be 3q plus 15 equals 3 square roots of q. So when we raise both sides to that 2nd power, understand that you are raising that 3 to the 2nd power as well. So that will be 3 to the 2nd power, which is 9. And then the square root of q will just simplify out to be q. Okay, so you can simplify that out from there. Really not difficult. Or check your notes. Check the key a little below. Now, for number 13, we're going to do the same thing. We have got that. I mean, when you are in doubt and don't know what to do, just know that you need to isolate that radical first. That's what you are trying to do first every single time. Go back up here and check in these instructions. We're trying to isolate the radical on one side, then we will raise it to the power of that index. So we're isolating this radical. We've already done that, so we're raising it to the power of the index. We're already on step 2. So that'll be 8x equals x squared. Now, you have done a problem like this before. This is why we do the radicals unit after we do factoring and solving by factoring, because we're going to subtract 8x from both sides, and that will leave us with x squared minus 8x equals 0. Now, this is not a trinomial, this is a binomial, so we can't do the drop the first sign, second sign tells us whether they're the same or different. We can't do trinomials in basic factoring, but we can take out a GCF of x. And that'll leave us with x times x minus 8 equals 0. Now, both of those are factors. So we're going to set x equal to 0. That's our first solution. And we're going to set x minus 8 equal to 0. You guys remember this. We have covered this before. So our two solutions here are 0 and 8. So now we just need to check it and plug it back in. And we'll plug it, again, we always plug it into the original problem. So 8 times 0, the square root of 8 times 0, does that equal 0? Yes, it does. Does the square root of 8 times 8, that will be the square root of 64, does that equal 8? Yes, it does as well. So our two answers are 0 and 8. For number 15, I'll just keep right on going down the row. So for number 15, we already have, I'll do it in blue. we already have the radical isolated, so we are just going to go ahead and square both sides. We'll be left with 6m minus 38. I'm going to write a little smaller for this one because you need a little bit more space. And then m minus 5 squared, again, you can't put it as m squared plus 25. You need to write this out twice, m minus 5 and m minus 5, okay? So what we will do here is FOIL. So that will be m squared minus 5m, which is going to give us minus 10m, plus 25. And now we'll do the same thing that we've done before. We've done this with warm-ups. I love these. You guys hate these. But we need to get them all to the same side. So we're going to subtract 6m, line that up underneath the 10. We're going to add 38, line that up underneath the 25. I'm just doing multiple steps in one. So we're going to be left with m squared minus 16m plus 63, and that will equal 0. So from here, we are doing our two sets of parentheses. What do we do with the first sign? We drop it. The second sign tells us that these two signs are the same. Then factors of 63 that will add to give us 16 are 9 and 7. So our two answers here are positive 9 and positive 7. Now again, we're not done. We have to check it, right? So I'm just going to go ahead and multiply that 6 by the 9, and that will be 54, right? 54 minus 38, and that'll be 9 minus 5. All right, so 54 minus 38 would give us, let me double check. 9 times 6, 54, yep. And that will give us 16. And then that will be 4 equals 4. So yes, that one works. We know that 9 is good. And then from there, we can do 7. 7 times 6 will be 42. 42 minus 38. And then 7 minus 5. That will be the square root of 4 and 2. And yes, that works as well. So 9 is also good. Now, number 17, this will be one where you can sometimes, if you have two solutions, sometimes one will work, sometimes one will not. You'll see that example in number 14. But sometimes neither of them work, right? Sometimes you just have no solution. So for number 17, we're going to do one just like we just did, where we are squaring both sides because that radical is already by itself. And instead of writing the 2, I'm going to write y minus 11 twice to save a little bit of space. So they'll give me y squared minus 22y plus 121. So we're going to do the same thing we did before. We're going to combine like terms and get them all on one side of the radical sign, or one side of the equal sign. Wow, dealing with a lot of radicals. And that will be y squared minus 17y plus 70. All right? And then we are asking to factor this and solve. So what do you do with the first sign? You drop it like it's hot. Second sign tells you they are the same. Factors of 70 that will add to give you 17 are 10 and 7. So our two answers here are y equals 10 and y equals 7. Now, we need to check these. Always check it. So 51 minus 5 times 10 is just going to be 50. We're going to see if that's the same as 10 minus 11. This will be the square root of 1. This will be a negative 1. That is not true. Big X in red, so that does not work. Then we will also check 7. So 51 minus 5 times 7. The square root of that, and then 7 minus 11. Well, first off, you see on the outside over here that both of these numbers are smaller than 11, and we're going to have a negative. And we have a square root over here, so there's no way that that square root can equal a negative number. So even when you do 51 minus 35 on the inside, and even when you see that that's a square root of 16, that's not going to give us a negative number. So honestly, I could have just stopped right here and said, no, there's no way it's going to give me a negative number. That's not true. So our final answer here is no solution. There is nothing.